Good afternoon, students. So what we see in last lecture? All operators are known. Yes. Piecewise operator, arithmetic operator, logical operators, all are seen in last lecture. So now we start the next point. Comma operator. So what is comma operator? Yes. Desai, yes. What we seen in last lecture?
Oh, sorry, ma'am. I was absent.
Abhilasha. Huh?
I was absent yesterday. Sorry. I don't know.
Okay.
Sorry.
So today's topic is what? Comma operator. So multiple expression can be combined into one expression using the comma operator. The comma operator takes two operands. It first is the evaluates the left operand and then the right operand and returns the value of the latter as the final outcome. For example, what? Integer m, n, mean. After mean, there is terminal. So there is a semicolon. Then integer m count equal to 0, n count equal to 0. Then mean equal to, in bracket, m is less than n, m count plus plus, comma, m colon n count plus plus, comma, n. Here, when m is the less than n and m count plus plus is evaluated and the value of m is stored in mean variable. Otherwise, n count plus plus is evaluated and the value of n is stored in mean. This operator can be used in multiple assignment in for loop. For example, for in bracket integer I equal to 0, comma, integer j equal to 1, semicolon, I less than equal to 10, semicolon, I plus plus, and j minus minus. Then the size operator. This will also seen in last lecture, na? The size operator. Yes, I was completed. Scope resolution operator. This will be, yes, this is not. So memory management operators, that is new and delete. We use dynamic allocation technique when it is not known in advance how much of memory space is needed. C++ supports the define of two unary operator and new and delete that performs the task of allocation and freeing the memory in a better and easier way. Since these operators manipulate the memory on the free store, they are also known as the free store operations. An object can be created by using new and destroyed by using delete operator as and when it required. A data object created inside a block with new will remain in existence until using delete explicitly destroys it. The new operator can be used to create objects of any type. It takes the following general form, that is syntax: pointer underscore variable equal to new data type. So here pointer underscore variable is a pointer of data type of data type, and the new operator allocates the sufficient memory to hold a data object of data type and returns the address of the object. So the data type may be any valid data type. The pointer variable holds the address of the memory space allocated. For example, p equal to new point, q equal to new float, semicolon, where p is the pointer of type integer and q is the pointer of type float. Here p and q must have already been declared as pointer of appropriate types. And alternatively, we can combine the declaration of pointers and their assignments follows. So in star p is equal to new integer, float star q equal to new float. Subsequently, the statements star p equal to 25 and star q equal to 7.5 will assign the 25 to the new created integer object and 7.5 to the float object. Then typecast operator. C++ permits the explicit type conversion of variables or expression using the typecast operator syntax. Type name expression, for example, average equal to sum divided by float of I. So type conversion, simple type conversion, a value in any of the built-in types we have seen so far can be converted the typecast and to any and the other types. For example, 3.14, that is the integer, converts 3.14 to in the integer to give the 3. That is whole number of this integer 3.14. Next is the double. Double 2 converts the 2 to the double to give the 2.0 and onwards. Then character 122, it converts the 122 to the character whose code is 122. As illustrated by this example, the building type identifiers can be used the type operators. Type operators are unary, that is, take one operand and appears inside the brackets to the left of their operand. This is called explicit type conversion, when the type name is just one word and the alternate notation may be used in which the brackets appear around the operand. Integer 3.14 is same as integer 3.14. Then stream manipulation operators. For formatting, the data display manipulator operators are used. Normally, used with extraction operator to modify the or manipulate the way the data is displayed. These are present in iomanipulate.h header file. Some of the useful stream manipulators are DEC, sets of base 10 integer, that is decimal. Then NL, sends a new line character, ends, sends a null end of string character. Then flushes an output stream. Then heads, sets the 16-digit integer. Then oct, sets a base to the 8 integer. Set W integer, sets field width. For example, count A and L, count B and L. Here and L is the stream manipulator causing a line feed to the inserted into stream. Thus, value of A and B are displayed on two different lines. Then scope and visibility. The scope or visibility of a variable determines the whether it can be accessed from other functions in the same source file or in the other source files. The position of an identifier within a block is also a factor in determining scope. Scope and visibility. The scope or visibility or a variable determines whether it can be accessed from other functions in the same source file or in other source files. The position of an identifier within a block is also a factor in determining scope. In other words, it is that part of a program over which the identifier can be seen by the other identifiers and used by the other identifiers. Then external variables. It defined outside any blocks and memories for this is allocated once. Even through the external variable is declared more than once, it only has memory allocated to it once. Variables can be declared as global variables and available to the everything. These are also known as external variables. So external variables are defined outside of any functions and return their values during the course of a program. Then static variable. These are variables that are local to a function but which return their values between invocations of the function. These are internal static variable. The second kind of static are external or global variable that are local to a file but not a part of any function. The main use of this is the hide the variable so that other source code file don't see the variables. Static storage comes from a different memory location. It is allocated from a static area of memory. So static variables within functions can return their values between calls to functions, and static variable can be initialized to the some value other than 0 but will only be initialized at the first call. Then automatic variable. Inside a function, doesn't it mean doesn't exist until the function is called. At the time, the memory for the automatic variable is allocated dynamically from a memory stack and released when the function is finished. Auto variables are not initialized at startup, but each time they are called and do not return their values. Then global variable. It can refer anywhere in the code. It can be referred anywhere in the code within any function whenever it is faster its declaration. The scope of the local variables is limited to the code level in which they are declared. If they are declared at the beginning of a function, like in main, its scope is the whole main function. This means that if in the example moreover the function main, another function exists, the local variables declared in the main would not be the other function and vice versa. For example, say hash include iostream.h. Here integer int integer semicolon character characters character string of 20 unsigned integer numbers number of sons, then main function unsigned short age float a number, another one, then see out enter your age and see in age. So int integer to unsigned integer number of sons. These are what? Global variables. Then unsigned short age, float a number, another one. These are local variables. And see out and see in the is the instruction. So the scope of local variable is given by the block in which it is declared. A block is a group of instructions grouped together within curly brackets. If it is declared within a function, it will be variable with a function scope. If it is group of instruction grouped together within curly brackets. If it is declared within a function, it will be variable with function scope. Then if it is the declared loop, its scope will be only the loop, etc. In addition to local and global scopes, exists the external scope that causes a variable to be visible not in the same source file but in all other files which will be between the link together with. Then control statement. Control statements are ways for a programmer to control that pieces of the program are to be executed at certain times. The syntax of control statements are very similar to the regular English and are very similar to choice that we make every day. There are two basic types of control statements. First is branching statement and loops. So in branching statement, depending on certain conditions, a certain series of events executed will be executed while loops let the user to have certain part in the program to be repeated depending upon the terminating condition specified in the loop. Then control structure in C++. First is what? Selection, or that is called branching, and iterative, that is loops. So also types of selection, that is if else and switch case. And in looping there are for loop, while loop and do while loop. First is the branching statement. If statement, first is if statement. Use the if statement to specify a block of C++ code to be executed if a condition is true. Then syntax is if condition in curly bracket, there is a block of code to be executed if the condition is true. Then note that the if is lowercase letters, uppercase letters, if or if will generate an error. In the example below, we test the two values to find out the if 20 is greater than 18. If the condition is true, print some text. So example is hash include iostream.h using namespace standard integer main in curly bracket. If 20 is greater than 18, see out 20 is greater than 18, curly bracket complete, return 0, curly bracket complete. Then our output is what? 20 is greater than 18, because our if else if statement is true. Then next example, hash include iostream.h using namespace standard integer main in curly bracket, integer x equal to 20, integer y equal to 18. So if statement x is greater than y, see out x is greater than y. So here if statement is true, then print this x is greater than y, return 0. So here 20 is greater than 18 is true. So our output is what? X is greater than y. The else statement. The else statement. Use the else statement to specify a block of code to be executed if the condition is false. So syntax, if condition, then in curly bracket there is block of code to be executed if the condition is true. else the block of code to be executed if the condition is false. After that statement is going on. Then hash include IO using namespace standard integer main in curly bracket integer time equal to 20. Hash include IO using namespace standard integer main integer time equal to 20. If time is less than 10 18, then in curly bracket see out good day, then semicolon else see out good evening, return 0. Our output is what? Good evening. Example explained is in the example above. Time 20 is greater than 18, so the condition is false. Because of this, we move on to the else condition and print to the screen good evening if the time was less than 18. The program would print good day. The Elsif statement. We use Elsif statement to specify a new condition if the first condition is false. Syntax: if condition, then block of code to be executed if condition 1 is true, and else condition 2, the block of code to be executed if the condition 1 is false and 2 is true. Then else block of code to be executed if the condition 1 is false and condition 2 is true. Sorry, false. For example, hash include IOStream using namespace standard, then integer bracket, in curly bracket there is integer time equal to 22. If time is less than 10, in curly bracket there is see out good morning. Then else if time less than 20, then see out good day. Else see out good evening, then return 0. So here our output is what? Good evening. So example is explained in the example above. Time 22 is greater than 10. So the first condition is false. The next condition in the else if statement is at also false. So we remove on the else condition since condition 1 and condition 2 is both false, and print the screen good evening. However, if the time was 14, our program would print good day. Okay, then next point is shorthand if else, that is ternary operator. Today we will stop here and we will see in